In a class where data and member functions are put together, data privacy is something we would like to enforce. For this, we want to prevent the user or client code of the class from accessing the data member. This does not mean that we don't want the client code to use the data. Without letting access to data, the class will have very little usefulness. Therefore, we allow the client code to access the data, but we allow it indirectly in a regulated or customized way. Member functions are the place where we define the nature of such regularization and customization. Let me try to understand this more through a quote. This code is outcome of the previous recording, part 1 of this topic. If you watch previous recording, you will understand this code better. Anyway, I will quickly describe this code first. We have the student object, student struct with the data member's name, pointer member, and integer ID. And we have the object of this myMarks type, which is to hold the marks and number of marks, marks in the dynamic array and number of marks in this member. We have the member function to set the data, ID, name, and the marks object data into these members. We have a display function to display that data. We have a deallocate function to release the memory. And we have a client code in the main function to test or to use to create an object and to use a set, display, and deallocate function. A problem with this code is that this ID, this members, I can access, or this the client code or a code which is not in the scope of this class is able to access this members name, ID, and this object, in addition to set and display. You can be sure that we are able to call this function. That means these functions are accessible from this place. In addition to that, you can also access the ID. I can directly access ID and set to something different, 9999, something like this. I can access name and maybe I can reallocate it, new to store this text. Then we can copy to it, like this. And after that, if you display, then after that you can also do some changes to it. Let me just change the fourth character, fourth character to Z. And after that, display. So we have access to the data from the outside code, from the client code. Let me make sure that we don't have issue with this code. So for that, I will switch to the terminal and try to compile it and execute. So we have, you can see the change we made from Jackson, where the client was able to directly access the ID and name and change to different name. So this sort of direct access by the outside code is something that is not desired. We don't want arbitrary or all-out access from by the outside code, by the user code. So this is not desired. So we want to actually regulate. We want to prevent this kind of access. For that purpose, we implement something called data privacy. Principle of data privacy expects that the members variables or member objects of the class which are carrying the data are set as private to the class, so that they are accessible only within the scope of this class. by the functions. These functions will be able to access, but they are not directly accessible from the outside code, the external code. Therefore, setting it private will not allow the client code to access it directly. The way of doing setting it private is you can use a keyword called private followed by colon. This is the label that will actually mark beginning of the private members. That means from this label afterwards, everything that we put is private to the class. So name becomes private, ID becomes private, this object becomes private, and even this set function becomes private, display function and deallocate become private. So if I run this, let me just comment this these codes out for a while. The code that directly access the data. So with this st object, it will not be able to access set and display. I'll show you by running this code. Switching to the terminal, compile. So it is already complaining, right? So this is a private member. It is not accessible from the place from where you are trying to access it. So when you make things private, you have to make only the things that are necessary to make private. And in the data privacy principle, we actually want the data to be private, and we let the client code access the functions or the logic that the client code can use to change the data, to access the data, to process the data, etc. So to make this set, display and deallocate function public, you can use public label. Right now, everything that becomes from private, this become private, and then everything that become after public, all become public. And by the way, if you don't put this keyword here, then everything is public in this case. Now you should be, this code should compile. So it has compiled and executed without an issue. In C++, a class can be created by using this struct keyword or also using class keyword. Only difference is that with struct, everything, all the contents are public by default. So if I don't put this keyword, then everything is public. That's the reason why we were able to access the set, display and even the data members from the client code. But if I change this struct to private class, then everything is private by default. In this case, name, ID, everything became private. So we at this point we will not be able to execute this code, compile this code, because this execution attempts will be an error, compilation error. Let me show you that. So it is complaining. The complaint is similar to what it complained when we actually changed, actually included the private label in the struct definition just before. Now, when we have a class keyword, then we can be confident about the data being private, but you have to, manually make the functions that are going to be used by the client code as a public by putting this label public here. Again, to the terminal, compilation, It's working. Displaying the data that we expected. Here I want to tell you one last comment. When you put these things, data members and functions together, you bundle together. This is the encapsulation, right? But one of the principle of encapsulation is that you need to encapsulate the data members and the functions in such a way that the data are private, the privacy of the data is maintained, and access to the data is provided to the client code through well designed the member functions. Thank you for watching this video.